Chairperson SS Professor SS Assistant Professor Dr. Panida Chanketgong. He from the College of Engineer, Rangsit University, Thailand.
Thank you very much for your announcement. And in my section, have two topics for presentation, and we just start now. And the first presentation in the title of the formulation of metakaolin-based aluminosilicate geopolymer for spray coating from Department of Material Innovation School of Science แม่ฟ้าหลวง by คุณ Pattarasuda Viensiri. Let she start her presentation now.
Yes, thank you. Okay, so hello everyone. My name is Pattarasuda for the School of Science at University, Department of the Material Science. I would like to present about my research is the formulation of metakaolin-aluminosilicate geopolymer for spray coating. And the first about the introduction of the degradation of the concrete. The problem concrete structure must withstand over time the violence action and the stresses in the valley development. Is called the reinforcement precipitation, leaving the steel susceptible to the corrosion. The carbon dioxide in the air form the acid solution in the moisture environment, which can react with the hydro-cement pair and the train of neutralize of the alkalinity of the concrete. The carbonation had a significant impact on the corrosion of the steel and effect to the degradation of the concrete. Certainly, for the concrete surface treatment, could be divided into two types, such as the organic coating and the inorganic coating. The organic coating is the most commonly used due to its good protective performance. And however, there has a concern on the limit survival life and instability under UV light and on the durability in fire resistance. For the geopolymer coating is a class of new inorganic coating has the raw material are the mostly eco-friendly for the natural, mineral, or the industrial waste, and the geopolymer can be the formulation at a low temperature with a phasing environment due to lower greenhouse gas emission and have the good property in the thermal resistance, chemical resistance, and hydrophilic. And the geopolymer is a closed-link aluminosilicate structure synthesized by the chemical reaction to get the geopolymerization of the aluminosilicate powder with the alkali solution and get the geopolymer slowly and used into the spray coating in for the research. And the objective to study of the metakaolin-based geopolymer coating by varying the molar ratio of the silicon per aluminum from 1:2 molar ratio and the sodium per aluminum is equal 1. Then selection of the solari condition as appropriate for the spray coating and to study the appropriate of the thickness geopolymer solari for spray coating on the concrete. The geopolymer space was mainly prepared from the metakaolin and used alkali activation or the alkali solution is the sodium silicate and sodium hydroxide. The sodium and aluminum molar ratio is big at equal 1, and the silicon per aluminum ratio were given in the table shown in this picture. And the flow chart for the experiment, geopolymer coating by testing. The first is the setting time of the geopolymer slowly and test amount of viscosity to get the appropriate to use in the spray coating. Follow the ASTM and spraying with the spray gun and investigate about all the thickness, and the characterization is the XRD, FDR, and SCM for investigate all the geopolymer slowly. The methodology was mixing all of the raw material and test about of viscosity at the setting time, and when get the geopolymer slowly into the spray gun and coating in the cement mortar in the food system for the safety life, and get the result and the discussion. The first result is talk about of the setting time is shown in this picture on the orange line, and the requesting trend of the specimen. The silicon per aluminum ratio is into the M1.0 until the M1.4 have a decreasing trend and constant slightly in the M1.5 and M1.6, and further increasing of the silicon per aluminum ratio in the M1.7 until the M1.9 is the second time starting in the increasing again. And however, with the specimen with the silicon per aluminum of equal to is mixing unsuccessful because the sodium ion from the sodium hydroxide was insufficient to dissolve the metakaolin. And for about the viscosity is stereo coating after mixing, after in 5 minutes after the mixing raw material for the 2 minutes. The result getting show the picture in the blue line. It had the same setting time. The viscosity of the slurry has sharply as silicon per aluminum molar ratio has increased. The period of the M1.5 and M1.7 because in the region of the geopolymerization and the setting occurred quickly. The slurry of the viscosity for spray coating should not exceed 1 Pascal second according to the standard of ASTM. Our M1.5, M1.6, and M1.7 elicit pass this the standard. After the M1.8 and M1.9, there was an increase in the viscosity due to the increasing in the silicon per aluminum molar ratio because in increasing the sodium silicate, because the increasing the viscosity of the sodium hydroxide decreasing is what insufficient for the dissolve the metakaolin. And the experiment to select the slurry for use in the M1.5, M1.6, and M1.7 for where in sparing on the cement mortar, the coating with the M1.5 and M1.6 had a crack occur across the coating surface after the drying. Due to the drying silicate has a slurry has a higher water content, the M1.7 specimen has some crack around in the edge. This had a least crack due to the lower drying silicate. In the M1.5 and M1.6, there was more sodium hydroxide in the slurry than the N1.7 specimen. The N1.7 is the formulation was then selected for the filter investigate for the technique hosting the slurry. And the phase identification of the metakaolin was not that the metakaolin showed the typical the amorphous phase with intestine, the anatized and pores. And when the silicon to aluminum roller ratio have increased, the show above of the formulation is the amorphous phase observed in the other specimen was approximately, and it showed the when silicon per aluminum ratio increased, the geopolymer display varying degree of the geopolymerization, which would be the discussed using the FTIR analysis. And after geopolymerization, the typical the peak relate of the asymmetric in this line in this peak to show the silicon oxygen T. The T is mean the maybe it could be possible to use the silicon or aluminum bond in this show different from the base of the metakaolin. And due to the geopolymerization reaction, there was a noticeable change the formulation group in both of the aluminum and silicon, the result product of the new product with different chemical environment than the metakaolin. And the experiment, the slurry of specimen M1.7 were speckled on the Simenota. The formulation was then selected for investigate the thickness of the coating layer. In the first coating, the show in the picture after the first coating, there was very area in non-uniform thickness due to the insufficient to the coating, and after the second and third coating, the surface becomes smoother with no visible crack on the surface due to the sufficient of the concrete coating. And after the fourth coating, a few wrinkles show in all observe that the coating layer has no crack on the surface. And after the fifth coating, obvious crack were observed. The porosity of the geopolymer coating layer is shown in this cross section to show the thickness average to the cross section, and the bond interface between of the geopolymer slurry and the substrate was compact and a tightly bond, and the graph shows the thickness of the coating at valence ratio. And the conclusion, the appropriate the viscosity of the slurry for spray coating according to the ASTM following was silicon per aluminum roller ratio is 1.5, 1.6, and 1.7. All of the geopolymer coating show the amorphous phase with the functional group of the symmetrical, the static shift vibration of the silicon oxygen T bond and the spray especially with silicon per aluminum molar ratio of the 1.7 was found to be suitable for the coating, and the thickness of the coating layer as appropriate, around 3 to 4 layers with a thickness around 60 to 80 micrometers. Thank you for your attention.
Thank you, Pattarasuda presentation. And let's ask the question. Any question? A question, please.
I have one question.
Yes.
This is very good presentations, Ms. Pattarasuda. Will you go back to slide before the conclusion? Yeah, before that, yes. Could you give the reason why there was a crack in the first layer?
In the first layer, right?
Yes.
Yes.
In one layer, sorry, for one layer.
Yes. For the first inputting, the first coating the spray above of the quality to spray on the surface is not enough for the one layer, and the coating they insufficient to coat all around in the surface enough.
Okay, and what is the optimal numbers of layers you suggest?
I suggest in around 3 or 4 layers because they have enough for to the they can absorb the coating around on the surface is can enough to use.
Okay, and from what I observed, 4 layers and 5 layers, there is some small line in
Yes.
is that the crack or what is it?
It just all about of it. Just it's not cracked. Actually, in the 4 layer, it's not cracked because it have a little bit of about a wiggle in a little bit, but it's not cracked. And for the 5 layer, they have the limit of the enough for to the coat in the surface and occur the crack around in 5 layers. And above of the 4 layer, they have any no crack, just a little bit of the wiggle somewhere. It's a little bit.
Okay, thank you.
Thank you for your question.
Any question? Okay, and now I have one question. What do you expect that you coat geopolymer on the concrete?
I expect for aspect 2, the coating layer for to the treatment all about the surface, and the geopolymer base is high the alkaline solution is a pH. They have the high for to the protect about of the when the moisture is attracting into the surface. They have to use for to help about of the moisture into the concrete surface.
And do you measure another property from the coating? I mean, the strength or anti-drop or something like that. Did you study it?
Because in for it is the first my research, and actually I have to test about of the adhesion strength of the coating, but I have the limit of time, and this have to continue for the user director for the conference, and I have the limit of time to testing about of the adhesion strength, and it is a next time to test about of the adhesion strength.
Yeah. This one is very good. It's very good material to test everything, and I think if you compare with wood, it's okay. Okay, I will
in the wood substrate, right?
Yeah.
I see.
I will see your research in the next maybe in the next year presentation.
Maybe, yeah.
Yeah. Okay. Any questions? No. Okay. Thank you very much. Pattarasuda นะคะ